Hello, welcome to Lab 4 for STAT115 and 215. I'm Gigi Ken. I'm your TA for this lab. So this lab is mainly talking about the second part of homework 2. So before our lab material, I'm going to give you some announcement. So first of all, homework 2 is due this Sunday, February 21st, 2021 by midnight. And after homework 2 submission, please finish the post-homework survey. We're going to give some bonus point associated with it. So please do that. And just to clarify, our lab hour is every Tuesday from 6 to 7:30 p.m. And Thursday 8 to 9:30 p.m. Our TA hour is every Friday 4 to 5 p.m. And Saturdays 10:30 to 11:30 a.m. So if you already watched this video or you attended the Tuesday lab, you don't need to attend to the Thursday lab. You can pick one to attend. But if you have questions associated to the homework or to the lab, to the lecture material, you can get to us both on the lab hours and on the office hour. We're going to be happy to answer your questions. So for today's material, we're going to talk about this machine learning parts. We're going to talk about KNN, ridge, lasso, elastic net, cross-validation, logistic regression, SVM, random forest. So before everything, we need to install these packages and load these packages. So if you have not installed these packages yet, you can use either install the packages or VLC manager install to have these packages installed. We're going to need them for the homeworks as well. So just a brief introduction on machine learning. So one of these most important function of machine learning is to do pattern identification. So there are two parts. The first one is classification. Second one is clustering. So classification is supervised learning. So that means your input should have already have labels associated with it, so that your algorithm can identify these predefined labels and learn from these predefined labels and its associated variables. Then if you input another data to it, it's going to be able to assign a class to that new input. Whereas for clustering, is unsupervised learning. So you don't have any predefined labels. You only use the data provided to identify the similarities and try to group them together. So such as the k-means and UMAP. So the first one we're going to talk about is the KNN. So you use the first k closest neighbors for each member of the test set by comparing the variable x for training data to the comparable x. And based on vote using these neighbors, you assign a y to the test data sets. So k-nearest neighbor is one of the simplest machine learning algorithm based on supervised learning techniques. It assumes the similarity between the new case and available cases and put the new case into the category that is most similar to the available categories. It stores all the available data and classifies a new data point based on the similarity. This means when new data appears, then it can be easily classified into a well-suited categories by using KNN algorithms. KNN can also be used as for regression, but it's mostly used for classification. So here is a brief example of KNN. So we say like this a green circle as the new input. And if we set k equal to 3, so we take only the 3 nearest neighbors will be these 3. So these two red triangle is going to vote for red, and this blue square is going to vote for blue. So in this case, 2 is greater than 1, so this circle is going to be color red and be put into the same class as the triangle. The triangles are. And if we increase the k to 5, then we're going to have these 5 neighbors included into this voting set. So the 3 of these blue squares going to vote for blue, and the 2 red triangles going to vote for red. In this case, the circle is going to be colored blue. So the K is really important in KNN. So different K is going to give you different give you different predictions. So how to pick a good K? The answer is we use cross validation to get the K gives us the highest accuracy for test data. I'm going to talk about cross validation later. So let's proceed to another example of KNN. So here we're using the leukemia data set. We take only these 3 classes, the ALL, the AML, and the NOL. So before everything, we need to do some data cleaning. So we did some data cleaning, and because the leukemia data set is really large data set, it has several 30-ish something of the patients and thousands of genes. So so to save some computational power and to save time, we first did a PCA on this data set, and we take only the 20 most variable, the 20 principal components with the highest variance, so that we have a much smaller dimension, and then we split it into test data sets and the train data sets, and we store the labels into type train and type test. And then we use this train control function to specify a control, which we use the cross validation actually it's a 5-fold cross validation. And we measure the metrics of accuracy. So we use this function train to train KNN, use method KNN to train k-nearest neighbor classifiers. And then the control is going to pick the best K for us. We set the K range from 1 to 10, and the control is going to help us to pick the best one from it. And then we use this pre-trained KM to predict the label for a test data set. And we used the confusion matrix of this prediction and the real labels of this test data set. And we can see from here, the classifier did a pretty good job classify the ALL and the NOL, whereas we see the accuracy is 100% and 100%. However, for the AML, 2 of them are misclassified as ALL and 3 of them are misclassified as NOL. Just 1 of them is predicted correctly. So it's not doing a very good job on AML. It's probably because there is a close, like ALL and AML is very close together. And yeah, it's just probably because AML doesn't have a very dense cluster itself. But we want to see the accuracy, we got 0.6875, which is pretty good, because if our classifier is doing a terrible job, we're going to get something like 0.333. We have 3 classes. Yeah, so 0.6875 is still like an okay accuracy, but from this confusion matrix, we just know that AML prediction is not so good.